I want to invite the next speaker, Daniel Savu, who is going to be talking about modular blockchains and permissionless interoperability. Give it up for him. Jen?
Yeah. So I'm Daniel. I'm on the engineering team at Hyperlane. Today's presentation is about modular blockchains and permissionless interoperability. It's a mouthful, I know. But before we start, I'm curious, can I have a show of hands for who here already knows what a layer 2 is? Okay, I mean, it's pretty much everyone. Maybe I can speed through everything. Let's see. Cool. So yeah, going back to the last cycle, Ethereum pretty much outlived all of its killers. There were all of these new blockchains that claimed to do stuff, cheaper and faster than Ethereum. And I mean, actually they did, but by the end of last cycle, when it all came crashing down, they actually struggled to gain the community and liquidity to keep them running. So everyone came running back to Ethereum for a safe haven to kind of build their projects on top of. And many people pivoted to building on Ethereum or building Ethereum aligned, and myself included. Like, until last year, I was actually part of the Polkadot ecosystem. And well, now I'm at Hyperlane, and I'm here spreading Ethereum gospel. But the big question is now, Ethereum is amazing, it's secure, but can it support billions of users? Can it support decentralized compute at global scale? And please, another show of hands now. If you ever wanted to submit a transaction to Ethereum mainnet, but ended up not doing so because it was just too expensive? Exactly, like the gas is too damn high, Ethereum has a scalability issue. There's too many people wanting to send transactions to a fixed, well, more or less fixed block space. And obviously due to supply and demand, fees skyrocket every time. But thing is that there's some really smart people in the Ethereum community, and they worked to figure out ways of scaling it. And the solution that the community ended up going for is to execute transactions outside of Ethereum and then just settle on the layer 1. So the way that works, maybe it looks complicated, but it really isn't. Instead of sending transactions to the Ethereum layer 1, you send them to some centralized node that runs a virtual machine. And after it's done creating a new block as part of the rollup virtual machine, and by the way, rollup is just usually another name for layer 2s, although semantics can get mixed up. And the rollup executes transactions off-chain. It creates a new block and posts to the Ethereum layer 1 a result of executing those transactions of the state transition function of the rollup, along with data necessary to prove the validity of the block that just occurred in the rollup chain. So it's basically you have Ethereum, the blockchain, run what it usually runs, but then you have another blockchain run as part of the rollup sequencer. So hence the name a layer 2. And so yeah, we perform transaction execution off chain and post transaction data to Ethereum to be able to validate it on the layer 1. So even if this node is centralized, it's not necessarily a security vulnerability because this is just for batching stuff together such that the user pays less because the cost of posting to Ethereum is socialized with all the other people who transact to the layer 2. Cool, but there's several problems with layer 2s as they are now, or as they used to be until very recently. And one of them is the data availability problem. where it's still kind of expensive to transact on a layer 1. Like until very recently, it still cost maybe $1 or so to transact on a layer 2 like Optimism or Arbitrum, because posting data to Ethereum is like 80% of the cost of transaction fees to use a layer 2. And I'm sure maybe most of you are already aware of the Denkun upgrade, and we have blobs now. Presenter earlier already mentioned ephemeral storage, and that reduced the cost of posting data by, let's see, 10x. So now it's 10x to post data to Ethereum. You know, transactions are cheaper. Now it costs about 1 cent to do a swap on ZK Sync or some of the other rollups. The problem with these blobs is that they don't scale the more users we have. Like, okay, it's now 10x cheaper to post data to Ethereum, but if we get 10x the number of rollups or users, then we're kind of back to square one. And yes, we have a bigger community, but still this isn't future-proof. And full dank sharding, which is supposed to solve this as part of the Ethereum chain, is still years away. So that was one problem, the data availability one, but there's also the VM problem. Ethereum runs this thing called the Ethereum virtual machine, basically has you write code in Solidity, which is a bit of a loved and hated language at the same time because it's so established, everyone knows it, but it's very easy to shoot yourself in the foot and introduce security vulnerabilities in your code without wanting to. And then the other thing is that the EVM was never supposed or implemented for performance. It's like the single-threaded thing where it executes transactions in sequence, even if they have nothing to do with each other, and you could very easily parallelize them. So there's better alternatives out there for virtual machines. Like Solana came up with this thing where you can parallelize transactions, so they're much cheaper because you compute them faster. Move, which is the virtual machine ran by the Sui and Aptos blockchains, is kind of secure by design and makes it virtually impossible to write re-entrancy bugs. But like we can keep Ethereum, it's amazing, it's secure, but keep it as the settlement layer to secure the layer 2s and solve all of these problems like data availability, virtual machines. We can still solve them at the layer 2. Basically, innovate where all the Ethereum killers tried to innovate as part of these layer 2s. This is actually my old set of slides. Let me just skip through some of this stuff. If you think back about the diagram that I showed earlier, you've got the sequencer node, which is that centralized node that people send transactions to. It basically does transaction execution because it has its own virtual environment, and then it posts stuff to a contract on the Ethereum layer 1. And the contract on the Ethereum layer 1 could be considered the transaction validation layer because it makes sure that the state transition of the rollup is correct. And then the Ethereum blockchain itself is in charge of ordering the blocks, ordering the history, basically of the rollup as well, and of keeping transaction data around. So how can we innovate at the layer 2? We can take those things, data availability and the VM issues, and kind of specialize them. We can treat them as separate blockchains and decouple them from one another and implement something completely novel and new. And as a more visual explanation of what I just said, until now, Ethereum used to do all of these things like transaction execution, transaction settlement, and the data layer. And it still does, but if we want to scale, we should try to move some of these things elsewhere. Like execution layer can be the rollup, Ethereum stays as the settlement layer, and you can use something else for data availability. And to give you some examples of this actually happening in the real world, we've got Manta network. So all of these 3 examples are layer 2s that settle to Ethereum. Manta network runs an EVM as part of the rollup and uses Celestia for data availability, which is way cheaper than data blobs. You've got Eclipse, which is a layer 2 that uses the Solana VM and again posts data to Celestia. And similarly, M2, which is still in testnet, that runs a Move VM and posts to Celestia. And so the common theme here is that most of these new layer 2s, modular layer 2s, they use Celestia because it's like even cheaper than data blobs. It's like 10 times cheaper. And most importantly is that it scales with users. Like we can keep transactions or like the cost of posting data low, even if we get new users, just because of how Celestia works with light nodes that quadratically scale the throughput of data availability. So to recap, we need to scale Ethereum. Fees are too damn high. We can do that with layer 2s that innovate, on data availability and virtual environments. And let's look at how things are today. Like, if you go on l2beat.com, you can see that there's like 90 layer 2s, either live or pending launch. Danksharding, which is this Ethereum upgrade, will easily support hundreds of rollups. This is part of the official Ethereum roadmap. But then now you have people talking about long-lived layer 3s even, and ephemeral layer 3s. So it's pretty safe to assume that we're going to live in a future that's going to have hundreds of rollups, if not thousands. But if you also look on l2b.com at what the interoperability landscape is looking like, it's highly fragmented, where the top bridges out there all use more or less different tech stacks, and as a dApp developer, if you want your application to have access to remote users and liquidity in distant ecosystems, you pretty much have to maintain integrations with several bridges at once, like the bridge from the layer 1 to the layer 2, asset like token bridging integrations for other layer 2s, or like even general message passing if you want to send messages to a different blockchain. So that's one problem, fragmentation of bridging and having dApp developers have to put up with that. And then the other problem is that it's super easy to launch a rollup. Like if you go on Caldera's website, which is basically a rollup as a service company, you click 5 buttons or so, like you pick the virtual machine, you pick the native transaction currency, you pick the data availability layer, and like within 5 minutes, you have an up and running rollup. But you have a rollup and you only have a bridge to the layer 1. Like if you want to move assets or make a cross-chain call to a different rollup, you have to go through the layer 1 and incur the costs of using the layer 1, which kind of defeats the purpose of having rollups altogether. So this is where Hyperlane comes in, and we see interoperability as the missing piece of this like modular decoupling of what blockchains do. And we think that rollups out of the box should be able to come with interoperability. So basically, to reiterate, we have these layer 1s and already layer 2s on top of them, and there's going to be hundreds of them. But even on top of the layer 2s, you have layer 3s. And all the combinations, you basically have an exponential increase in the number of connections you can have between the various chains. And as a new rollup, currently, like today, your only option is to go to an established bridging provider, start lobbying them, pay them whoever knows how much, and basically find a slot within their timeline to launch a bridge on your chain months from now. This kind of kills your go-to market and makes it very hard to validate your unique value proposition to your investors and users. So that's one thing we do. We make it very easy. Can I go back? We make it very easy to self-deploy a bridge on a fresh new rollup. And it's completely on your terms. You don't need to come to us to ask us for anything, actually. So our code is open source. We have tooling to help deploy the contracts that comprise the bridge however you like it. Like you can configure the security of your chain. And we also provide open source agents to run the infrastructure of the chain. Basically the relayer that moves messages between chains and several other off-chain clients. So that's one value proposition we try to bring. And then the other one is basically a single interface that unifies how you do cross-chain communication. So if you remember what I said earlier about dApp developers having to support a bridge to the layer 1, a token bridge to another layer 2, and maybe some general message passing bridges to do cross-chain calls. You can actually have Hyperlane abstract all of that away and either wrap existing deployments of bridges on your chain or do those deployments yourself using our toolkits. And you can modularize the security of sending cross-chain messages either based on the content of a message or based on the origin of the message. It's all completely configurable. Like if you're sending a super high stakes message that maybe moves millions, maybe you want to use economic security, or maybe within the first week of your rollups life, you want to do something fast just to test that everything's working. You'll go for a multi-sig that you define, and you can later on change if you get a bigger validator set and so on. Or you can even aggregate existing bridging providers. Like say you convince Wormhole to finally deploy on your chain, and you love Wormhole, but you're probably concerned that there's a small chance they'll get hacked. You can do a 2 out of 2 aggregation bridge that uses Wormhole, but also a multi-sig that your company controls. So in case Wormhole is hacked, your bridge still isn't drained because it's very likely that the hacker will not have gained control over the multi-sig. So we see this modular expansion, we call it, as this explosion in the number of rollups, modular predominantly, that have kind of become enabled and possible because of the launch of Celestia, making it so cheap to post transaction data. And you're going to have rollups on top of Ethereum, rollups on top of Cosmos hubs, even sovereign rollups that take their security from their own validator set. And we see as a huge necessity there to have Hyperlane in between, just to make it viable to get access to new users and liquidity. We have some, lots of use cases to cross-chain, obviously. I'll just mention one. Aave is using us to do cross-chain governance, where they have a DAO and they do referendums and everything on one chain. But since Aave lives on several chains, whenever they take a decision, they kind of propagate that to all of their existing deployments, like N destinations once a DAO reaches a decision, and that automatically updates all the Aave deployments at once. Yeah, and I'll keep it short. I guess I mentioned a lot of things. I'm curious what you guys think, and if you have any questions. Yeah?
You have one. Sorry. Since you support, interoperability, basically, do you have to support all the layer 2s somehow? Because you don't know which layer 2 I will be using.
We try to.
Or do I have to? How does it work basically so that you
Yeah.
support all of this ecosystem?
So basically we have implementations for the VMs that I just mentioned. So we have EVM, Solana VM, and actually CosmWasm, which runs on Cosmos. So regardless of how you want to customize your layer 2, it's very likely that Hyperlane will be able to support that. At the moment, our self-deployment tooling only supports EVM, but part of our roadmap is to make it very easy to deploy regardless of what your layer 2 supports. Yeah. Any other questions?
So can Hyperlane be used to create L2 to L2 bridging?
Absolutely, yeah. L2 to L2, L2 to L3, or to L5 if you ever get there. To other L1s, we have a rollup that basically is a Solana VM, but has a native bridge to Ethereum that's Hyperlane under the hood. You can pretty much mix and match however you like. Yes. Yes, that's an excellent question. Well, it's because Celestia charges in TIA, which is their native token, in order to post data to it. And I guess you can do some swaps. at the time when you post data, but maybe if you have a rollup building on top of Celestia, you want your DAO or whatever that is to already have some exposure to TIA in case there's some like price fluctuations and so on, and you want to have TIA on your rollup. So essentially, all of these new rollups that use Celestia under the hood, they want to have access to TIA on their chains, maybe to do DeFi or just to hold it in their treasury. So it's pretty crucial for them to have that bridge there. Yeah. Yes, yeah, for sure. Like,
Very cool.
There's no bottleneck there in terms of like, Hyperlane doesn't constrain you in terms of the data availability layer you use. You can use EigenDA, you can use a data availability committee, if so you wish, or even like, 4844 blobs. Hyperlane is just kind of like a consequence of this very varied landscape of layer 2s. They're all so different and there's so many of them, and the big question is how do you connect them? It doesn't really matter like how they work under the hood. You can have a sovereign chain, like you can take a virtual machine, start a new layer 1, and you can still use Hyperlane to connect that.
I have another question.
Yeah.
So I think your value proposition, it's a bit at the same level with what Wormhole does. What's the edge over Wormhole? Why should I choose this?
So as I said earlier, you need to ask Wormhole for permission kind of to deploy on your chain. Like you need to somehow reach out to them and set up a roadmap for having them deploy on your chain, and you need to pay them to support you as part of their core deployment. Whereas with Hyperlane, you can self-deploy. And it makes it very easy to upgrade. You don't get vendor lock-in essentially, because you have this contract interface that you can use to go to any route to reach other chains. But it also makes it very easy to upgrade providers. Like you can use Wormhole basically wrapped in Hyperlane, and if for some reason you stop liking them, or you get light client bridges, which is like as secure as you can get eventually on your rollup, you can switch from Wormhole to the light client bridge while still having your interface integrated with Hyperlane without breaking your smart contract deployment. So basically that saves you pretty huge hurdle of having fragmented liquidity with a new version of your smart contract. Yeah. Love it.
Yeah, it seems like you're hitting the right tone. That's why so many questions. There is a Bitcoin layer 2 movement coming up. Okay. And somebody asked me, hey, can you give me a good architecture, I'm a tech guy, on how to do the bridging and all these things. So is Hyperlane maybe suited for that use case?
I love this question so much. You know why? Because previous company I used to work for is now a Bitcoin L2. So yeah, as part of the Polkadot ecosystem, I used to work for this Bitcoin bridge, which is now, they're called Bob, like build on Bitcoin.
Yeah, I know.
Yeah, and I think we have a pretty close relationship to them and are discussing about how we could help them deploy using Hyperlane. So I mean, it's basically the same thing. They're Bitcoin layer 2, but they run the EVM. And since Hyperlane contracts support the EVM, you can deploy Hyperlane there. Obviously, we don't support like, I don't know, Bitcoin script or anything like that because it's so limited. But I guess the point with Bitcoin L2s is that they draw some of their security from Bitcoin. Similar with what I just said here was that with layer 2s that draw their security from Ethereum. So as long as you run a VM in your layer 2 that's compatible with one of the existing Hyperlane implementations, and that can be a community implementation as well. Like we've had people actually implement Hyperlane for the Move VM. It wasn't us. You can absolutely deploy it. Yeah. Awesome. Well, thanks so much, everyone.